In this diagram, we're given the circuit right here. We need to find this current through the 100 ohm resistor. To do this, we're going to use the mesh current formula, and we're going to define the direction of our current. I'm going to define the current of our system to be going this way. We can see that it is in opposition with this I right here, and we will have to come back to that in a second. I just kind of have the habit of drawing it like this, but if you draw it the other way, it's going to give us the same answer. We just have to kind of work around it a little bit differently. But after I have these in place, I'm going to draw the voltage direction. Voltage is going from this way, and same thing in here, it's going from positive into the negative. Now I'm going to solve for the individual parts of our mesh current circuit. We know that we have a negative 160 volts. This is because it's going in the opposite direction of our I1. Now we can add the resistors for our I1, so we're going to have a plus 110 ohms of resistance for I1. Then we have to subtract 100 ohms of resistance because it's next to our I2, and our I2 is going in the opposite direction. This is all set equal to 0 because of Kirchhoff's voltage law. Now we're going to look at I2. For I2, we have the negative 100 ohms, that's for I1 going in the opposite direction. So we're going to have negative 100 ohms, and this is for our I1. Now we can add all of our I2s together, which is the 100, 30, and 20 ohm resistor. This is going to give us 150 ohms of resistance for our I2. Now we have a voltage. We have 150 volts, and this is being multiplied by our I. We can notice that it's going in the same direction as our current, so we're going to have a plus here, 150 times our I. Now our I, we have to see what that is. We can see that our I is going this way. It's going in the same direction as our I2, and it's going in the opposite direction of our I1. So this is going to be I2 minus our I1. This will all be set equal to 0. I'm going to factor this in. I'm basically putting this in parentheses. The 150 is on the outside. I'm going to factor the 150 in and rewrite both of these equations to be a little bit neater. So I'm going to get this, and I could solve for I1 or I2 by hand, but I'm just going to plug it into a matrix. I'll have that link below. So in our matrix calculator, we are going to represent our x, or I'm sorry, we're going to represent our I1 as an x and our I2 as a y. Plugging these in just like this. I plug these in upside down, but it doesn't really matter. We just have to stay consistent again. So we get our x is equal to 6 and our y is equal to 5. Or that our I1 is equal to 6 and our I2 is equal to 5. Now we need to look back at our I, because this is the actual I that we want to find. It's going in the direction of our I2. So it's going to be equal to our I2. I1 is in the opposite direction, so we're going to have to subtract I1. So we're going to have a minus I1 here. Now we plug in our values. Our I2 is 5, our I1 is 6. We have a negative in between them, so this is equal to negative 1. That means our answer is negative 1 amps. And that is how you solve this problem. For more problems of Intro to Circuit Analysis, they'll be in a playlist linked below, as well as notes that'll help study for this material.